Hello everyone, Embedded Monkey here again in Embedded Adventure Day 17. Yeah, I know I skipped the previous day, but there was a reason. I began to sleep at 5 a.m. I guess you guys understand. In last series we actually explored some physics topic. We explored the R to R ladder circuit. That was pretty interesting actually, and I understand a lot of things, but I guess the actual ADC and DEC topic can be closed for now until I actually try to do something with them directly. So as for the DAC, I actually no like for the ADC, I have to actually buy some input peripherals like sensors or buttons to actually do something. So I hope that that will be next experiment series, like with LEDs. So probably I'll order them and actually try to do something. Because DAC we have already explored as the GPIOs. And today will be quite a chill video. I decided to explore this thing. I heard that that is a cool IDE for esp32, so I decided to install it. And today I'll just explore its capabilities. Maybe it's debugger, I don't know. And because I heard that it's it's extremely useful in terms of that you can monitor different addresses, different memory layouts, and all that thing. So probably I will try to do something. I have already installed its extension to the Visual Studio. So the plan for today is to just try to create a basic project and try to debug it. Maybe to look at different addresses and all that stuff. So I don't know. By the way, pretty weird decision to put it in Visual Studio. I thought they have like a separate desktop application, but okay. By the way, is it me or just web camera is a little bit broken? No. Like the FPS is very low. Okay, I hope you guys can see at least the screen, right? So the web camera. Well, okay, I will see. I will see. I hope you can at least hear me well and see the screen. Okay, just create the new project. I don't know. Let's say monkey project as usual. Monkey project board, of course ESP. Yo, like esp32. Adafruit, no, not Adafruit. Just a regular dev kit. Well, I guess mine is actually not from any of those. Like it's well, I thought it's like a do it dev kit, but it turns out it's even not dude. I can actually probably show you. There is no like naming on it. It's just simply, yeah, here's the back. So no do it logo. It's just like, I don't know, maybe it was customly done somewhere. Probably. Okay. But let's stick with this one, because this is a pretty common framework. Of course, CSP-ADF, no Arduino. Use default location. No, actually, I want a different location. We want a location here in Embedded Monkey. No, Embedded Adventure. Yeah, let's say we want it in Embedded Adventure. Finish. Okay, let's just wait for a bit. And I'm just curious because it's quite handy to check the different addresses and where your program or data is actually stored. So it's not only interesting, and it's also can help you to check like whether something wrong or no with this program. Seems quite long to start the project, but okay. Okay, let's, while it's creating, let's ask ChatGPT again. Yeah, let's ask him about what can I do in platformio and different things. I don't know. Let's check. Currently installed platformio, like IDE for esp32. I wonder what can I do there. There well, in particularly debugging, yeah. VS Code is a full embedded development environment for esp32, not just decoded their alpha, but especially on what debugging is possible in practice. Okay. So of course we can write some firmware for esp32, like using different frameworks, toolchain installation. By the way, interesting, what toolchain does it use? Because the esp-idf just have this simple weird file, idf.py, that does everything for you, but what internally it means, what it's like internal logic, what does it call, which tools, I don't understand, and that's a little bit concerning. So maybe here I'll get some explanations. Debugging on esp32, what's realistic and what's not, can be debugged, but how powerful it is depends on your hardware. Okay. Why so long? I wonder what has it created in directory already. Embedded adventure. Here's the monkey project. Well, not much actually. Not a lot, but okay, we'll wait for, like, I don't know, let's wait for next, I don't know, 3-5 minutes while I'm exploring, and then maybe I will just shut down this thing. Yep. Sorry, one moment. Just turn the phone off. Okay. So, first of all, serial debugging, most common and always available. This works on any esp32 board. What you can do: print values, states, errors using. Well, we could have done it actually with the simple print in ESP, in C code, because that worked fine. So I saw the messages in monitor window. Okay. Serial monitor shows faulty address, cold stack. Well, we could have saw that too on esp-idf. Starting the watchdog timers. Real breakpoints and stepping this through debugging breakpoints, step through variable inspection. One of those boards with built-in USB-G tag. By the way, says like ESP32S3, ESP32C3, and some ESP32S2. I just have a simple ESP32, like no postfix here. Okay. Most cheap ESP32 dev keyboards do not support this out of the box. That's sad, but okay. Hardware debugging, set breakpoints, step line by line, inspect variables. Pause free RTOS tasks. That's cool too. That's actually cool. View cold stacks. Debug multi-core behavior. Okay. You know what? Can I view memory layout and registers like in Kale UVision? Because I heard that there's a Kale UVision program. I probably can show you now, because I have it installed for a course in university here, Kale UVision 5. So we coded different things in assembler. There. Yep. Well, in C2, but in assembler in particular, I'm just gonna open, I don't know, some assembly code here. Here, yep. So we got some messy assembler code, and let's just turn the debugging here, and it shows me every register, every, you know, like port. I can see the memory here if I will just one moment. Yeah, so I can see the memory layout. So I wonder, can I do the same thing in platformio, like in terms of just see where the data is stored and how it is aligned. Yep. Memory layout and registers like in Kale UVision. Yep. But not as easy or as completely as in Kale UVision, and only with hardware debugging. The honest comparison to Kale UVision, well, it's actually probably better to say Kale microvision, because this is like the Greek letter. Okay. Kale gives you memory windows, register views, peripheral registers, and live updates out of the box. platformio and ESP32 can do this, but it relies on GDB plus OpenOCD, so the experience is more developer-oriented than GUI polished. Okay, I'm ready for it. What is required this Skrilla? You must have hardware debugging, one of these, ESP Pro, Link, SDAP. We'll probably try, but if this is true, like if only these ESP32's revisions support the debugging, well, then that's sad, because my board does not support it. But okay, we'll just see. How longer should I like wait? Okay, cancel. Well, I see the file that has been. I saw the directory that was like created, so why can't I use it? Okay, let's just open the project. Very strange ID, to be honest. By the way, there is no. I can't really see the project here. Pick a folder. Again. Bit adventure. Monkey project. Select folder. Okay, so now we finally opened that project. can I go just simply here? Okay, well, here, monkey project, open. Okay, so now I can actually write some code here. I want to just, I don't know, like test.c. Let's just simply copy the LED blink. So just to test. No, here. The blink, no. Simple. Well, let's take this one. Let's go with this one. Okay. So simply just using, okay, it already said that we can't use like prints for debugging, but let's imagine that we can. Okay, so now I want to somehow build that thing. Yep. So now I want to console SRC. By the way, let's check the official documentation of the platformio. Platformio documentation. Okay. Build configurations. Okay. Just, is there like a platformio get started? No, platformio build project. Platformio build project. Quick start. Let's go here. Okay. So this tutorial will introduce you to the base of platformio core. Okay. Initialize project. Project and need board. You know. So here everything is made through the CLI, as I can see. So we are just simply using the pio command. Okay. Board, you know, env. All right. Browse project CLI provides special pio run command too. So okay, first of all, we somehow init the project. Well, which we already did. So we have a project init with platformio. Now we write some code, and then we simply tell like the pio run, and that's it. I actually doubt that pio is actually path variable here. Yep. So probably have to add it somehow. Okay, maybe there's a different platform test runner, project tests. Here we got the framework, platform, and board. Yep. Station to the configuration. Oh, let's by the way check. Well, as I can understand, this is simply a configuration of different environmental variables, like in. It's probably similar to the officially esp32 menu config. So, okay. Anyway, can I access can access the one moment. So to open the terminal, just check, is there a pio here? No, no pio available. Okay. Debug boards. Start debugging. By the way, here it is. It just, yep, it just runs successfully. For some reason it couldn't be run like previously, but here we have a bio CLI successfully installed. Okay, can I just simply build the project? I don't want to flash it on the ESP. First of all, I just want to simply build it. Run project targets, build, upload, clean. Like, what if I want to just build it? Just to build and do nothing else. Run. Okay, let's just simply run the pio run here. Okay, it's interesting. So it downloaded different things. Packages. Python exam, platformio JSON. Oh, I guess I understand why it can't really access these script, because I have esp32 installed on different drive. Like, it's actually here. Probably I even can find what it looks for. Let's just simply, like, it looks for the esp32 scripts. What? Return. No, it's actually, if it actually looks for the esp32 on the main drive where the system is actually running, then everything should be okay. One moment, I'm gonna check. I'm gonna just simply check this directory here. And by the way, it took like almost all 3 space. I had like 4 gigabytes in the morning and it just completely destroyed it. Damn, I already hate this platformio, to be honest. Okay. Yeah, here, platformio. And, well, so the path seems to be okay. So I got all these directories are correctly listed. So I got the scripts, the Python here. Simply pip list format JSON, does it return non-zero? CMD options. CLI. Okay, maybe let's try to install this package manually. So we'll go here, just simply, okay, which version does it want to use? Like Python, exam, pip. Well, okay, so python exe pip install this nopyenv.cfg file. Let's take a look. Seems familiar, by the way. I have actually encountered this issue. The virtual environment in Python Windows. The virtual environment folder, the following files appear. Is a configuration file that stores information about the virtual environment, such as standard libraries, path, Python version. So by the way, here it is. Maybe we should run this command from this level. I'm just gonna simply copy. Damn, I like Python. I like that language. Okay, so we successfully installed that thing. Let's just try and run the what? From CLI. Let's just bio run again. Failed. Cannot remove an outdated IDF virtual environment. Please remove the folder manually. Why is it outdated? Okay, let's just obey this instructions. Delete that thing completely. Scripts. I guess we just should close the CMDs here. Just delete that thing. Bio run again. Creating a new virtual environment. But you know, guys, currently I don't really like my experience with platformio for the past 28 minutes, because how it differs from the using idf.py. Like, it's basically the same thing, but more like, more high level. So if well, not even higher level, it's like, it's basically the same thing. It just installs esp32 for me, and then it will just use probably idf.py under the hood. So the only reason to use platformio is basically for debugging. But probably I could have actually used, by the way, let's check, maybe Kale has the esp32 board. I just wonder, maybe I can actually develop some, okay, project, just close it. No, just just new UVision project. And no, we'll just try, maybe we'll succeed. Okay, embedded adventure, just Kale ESP. No ESP. No ESP. But maybe it's possible. SP32 development. Kale UVision. Yep. Sorry, microvision. Oops. Okay. Sorry guys, I'm just using VPN for different stuff, so I will not be allowed to read it. Okay. Can I develop apps for like not apps but programs? Yeah, programs for ESP32 using Kale Microvision. No, not in the way you're used to with STM. I'm not used to STM32. That's like the next level. Kale Microvision is not a supported or practical IDE for ESP32 application development. Below is the clear on its breakdown. It's not an ARM Cortex MCU. Collision is designed probably for ARM Cortex. Okay. So guys, probably Kale is not the option. Okay. We're waiting for that thing. By the way, I'll check how much. Well, not actually that much. 1 GB left. I hope it won't actually take all the free space on my drive. But I just wonder. Firstly, will it compile the same way? Secondly, will I be able to debug it? Okay, so it successfully says that it successfully created some image. Okay, so it actually took 239.82 seconds, but I hope it's like that only for the first time. Like, yeah, IDF compiles. IDF compilation also take lots of time. Okay, and now after I actually run it, okay, let's just see run inputs only, Okay. By the way, what does it actually process build all requires specified in platformio, build project, and upload firmware to the old device specified in platformio. Okay. By the way, let's try to upload that program. Just simply connect the ESP32 and just check. Seems like it was built successfully, so probably everything should be okay. One moment. Just for isolation purposes. But okay, like, I don't really. Damn. I already have a breadboard, but I still use this thing for isolation. Okay, let's just simply connect. Connected, glowing. Now let's simply pio run, target upload. Let's try run target upload. By the way, shouldn't I like specify the port that I want to use to upload? Yeah, by the way, it successfully discovered that I want to use port COM5, and currently I will show you guys, it's blinking. Yeah, so actually pretty easy to compile that thing on platformio. But what I really installed it for is for debugging. So I want to actually debug that blinking. Okay, start debugging. You don't have an extension for debugging. Should we make station in the marketplace? Find the app. Debuggers. Damn, I don't like that all that thing works simply on simply under Visual Studio. Like, why haven't they made like separate application for it? Clone git upgrade. Okay, let's just target clean uno upload. Further CLI guide. No, simply platform IO debug. No, like memory map. I just want to see memory map. Just interesting. Let's see. No, that's not what I'm looking for. It's like basically will show me the statistics of the elf file. So how does it call like elf file, like executable and linkable format? Yep. So I actually want to see like all these registers. Is there anything like that? Let your firmware footprint with platformio, generate a map file. No. Here. Maybe not map layout. See available flash memory. Yo. C registers, bro. Okay. I've successfully built and uploaded the firmware on esp32. How can I see the registers and memory layout of esp32? The CPU is halted via harder. Halted. CPU halt. Probably you guys can't understand this. I know. Halt. English. CPU halt in English computing is an assembly instruction that stops the processor from fetching new instructions, putting it in a low power idle state until an external interrupt. So CPU halt basically a state where instruction pointer isn't used. Like basically no instruction fetch occurs and probably no execution, or just no fetching. From fetching new instructions, putting into low power, okay. Until an external interrupt wakes it up, commonly used by operating systems to save power when no immediate tasks exist, though it can also halt entire systems if interrupts are disabled. Okay. If you have one of these, let's pretend we have one of these. Let's pretend, because I currently don't know which chip is exactly, but 99% that none of these, but we'll try. Cannot if you only have USB UART cable, serial print debugging. If you don't halt, the CPU registers do not exist for the debugger. Okay. Enable debug symbols. Build type debug. By the way, I probably have already specified it here. Yep. Oh no. Okay. Let's specify the build type debug. Okay. This gives symbols source level debugging. Okay. The debugging tool. Let's press. Okay. Okay, let's use some ESP built-in debug tool just to see. Start a real debugging session in VS Code, press F5 or click run, start debugging. Well, probably I should firstly run the pio run upload. No. Okay, ESP. And no debug tool ESP built in. Please use one of. Okay, let's use esp32. That is available. Probably it should work. Damn guys, I want to sleep. I actually woke up today at 5 AM I guess. Okay, so it says that version okay, now guys, I know that I have already skipped like one day of this embedded venture. That's actually sad, but the sadder thing is that I'm not able to actually be functional now. Probably, yeah. Since I slept really for a really small time, yep. But I hope I will remain consistent. Yep, I have some studying now, some intense studying now going on, but I hope I'll just continue, because the consistency is actually the key. Yep. The only thing why I have now like all of these successful embedded venture videos is because I was consistent and I was doing like this every day. I have skipped probably like one or two in previous ones, and today is the third. Yesterday was the third one, so yeah. Okay, that was embedded venture day 17. We explored a little bit of platformio. I actually don't like it already, because since it's pretty much just an extension for Visual Studio. But okay, I guess we'll give it a go tomorrow, and then I'll probably say, do I like it or not. So tomorrow probably we will actually stick to the debugging and finally see like the memory layout. I hope we'll be able to see it. I hope that version of that dev kit board is actually suitable for debugging. So yeah, that's the plan for tomorrow, just to see registers and different stuff on it. That'll be cool. That'll be cool. Yeah. So see you tomorrow, guys. Have a nice day. If you enjoyed this video, like it, subscribe, and leave a comment. That would be cool. Yeah. See you tomorrow, guys.